Hello everyone. In this video, we're going to be solving a polynomial equation. We have x times x plus 1 times x plus 2 times x plus 3 equals 35. And we're going to be solving for x values. What else can you solve for, right? Great. Now, to solve this problem, I'll be introducing at least two methods, but one of the methods could be incomplete. Sorry about that. I'm kind of lazy. If the problem is taking too long, then I'll just kind of give up. But you don't give up. Don't do what I do. Okay. So the first method is basically we're just going to distribute the whole thing and see what happens, right? Do it and see what happens. So to be able to multiply these things, there's a couple different ways to do it. Maybe we can just group them like x squared plus x, and then multiply this by x squared plus 5x plus 6. And then you can get 35 from here. I'm also going to show you an alternative method real quick, maybe somewhere in the middle. Well, maybe we can just talk about it right now, get it out of the way. So another way to approach this problem would be guess and check. Obviously, that doesn't necessarily give you all the solutions, or it's not always the best idea. But if you're taking a multiple choice test, imagine, hopefully, right, this comes up on a multiple choice test. It could, even when you're doing math competitions, because some of them are multiple choice, like AMC 8, AMC 10, AMC 12, even AMY, well, 1,000 choices. Good luck with that, right? But IMO, other high-level Olympiads, they're not multiple choice. Even if they were, it probably wouldn't make sense. But anyways, if you do have that chance, go ahead and use it. So you could just try some, what they're called, possible integer solutions. For example, can x be 1? Can x be 2? Can x be 3? Well, it looks like this is the product of 4 consecutive numbers. If you think about the product of consecutive numbers, like 1, 2, 3, 4, you're going to realize that every other number is even, right? Well, sort of. Well, 2 out of 4 will be even if they're consecutive like this. So the product will always be even. Uh-oh, Houston, we have a problem. 35 is an odd number, which means we're not going to be successful if we try to guess and check. But at least we tried. And guess and check is a problem-solving method. I know some people don't accept it. Too bad, but that's okay. So let's go ahead and distribute and see what happens. X to the 4th plus 5x cubed, and then 6x squared. I'm done with the x squared. And then plus x cubed plus 5x squared plus 6x. And then the whole thing is equal to 35. Let's go ahead and simplify this as much as possible. X to the 4th. I have 5x cubed plus x cubed, which is 6x cubed. We've taken care of this as well. I usually underline, makes it easier. Plus 11x squared. And then we have 6x. Use whatever symbols you like. Minus 35 is equal to 0. Beautiful, right? Yeah, not that beautiful, but, it's okay. So we can go ahead, and thanks to Nadia Fen again, I just want to emphasize that I really benefit from those comments. So we can solve it. How? We can actually go ahead and isolate these two terms and throw everything else on the right-hand side, leaving it like this. And then we can try to add something to both sides to make it a perfect square. So I want you to realize if you factor out an x squared here, this is going to look like x squared plus 6x. So can you guess the number? It's funny because I was tutoring a student yesterday, and this is one of the things that we were just talking about. What is it called? Completing the square. Yes, I do tutoring. Anyways, so I just said, okay, you take this number, and the student knew what to do. Good job. You take that number, coefficient of x, and divide by 2 and square the answer. What's half of 6? 3. If you square 3, you're going to get 9. So that's the number you need to add to make it a perfect square. And this just happens to be x plus 3 quantity squared, right? Awesome. Now, we're going to multiply it by x squared. So it's going to be like the product of 2 squares. Can you visualize? So in other words, this is going to be like this. Okay, I can kind of write it like this with brackets, kind of less confusing, I guess, if I use parentheses all the time. And then we're going to have this expression on the right-hand side. Whoa, whoa, whoa. We have a perfect square on the left, but not on the right-hand side. But don't worry about it because we can fix it, okay? Kind of like Bob the Builder, right? Okay, we can fix it. Now, to fix it, though, we kind of need to pay attention. This is some type of quantity. I'm going to call that y, and don't ask why. So we have y squared. We're going to add something to both sides, but that thing needs to be a variable, and it shouldn't contain, well, I shouldn't say that, right? It shouldn't just contain y, because then it wouldn't be helpful, I think, right? Would it? I don't think so. So we're going to add something like this. We have y squared. To this, I'm going to add 2ky plus k squared. See what I'm talking about? This becomes y plus k squared. And you know what y is, right? The whole thing, I called it y. So here's how it goes. And I can distribute. My y is actually x squared plus 3x, yeah? So now I have x squared plus 3x squared, which is y squared again, right? To that, I'm going to be adding 2ky, which is 2k times x squared plus 3x. Hopefully this makes more sense, plus k squared. So what did I add to the left-hand side? Let's take a look. I added this. So why is that important? Because I'm going to be adding the same thing, the exact same thing on the right-hand side. But we already have a bunch of stuff on the right-hand side. Let's leave it for now, and let's add what we're supposed to add first. Why? Because they're positive, because of the plus signs. Okay, we're going to add those first, and then bring the other part in, which is minus 11x squared, and then minus 6x plus 35. Now, what do I have? I have a perfect square on the left, and I should have a perfect square on the right-hand side. But what is on the left-hand side? Remember, that was y plus k squared. So now I'm going to write it as y plus k squared. Yes, this has 3 terms, equals this expression. When you distribute this expression and kind of rearrange the terms, you're going to get something like this. 2k minus 11x squared, that's the most important part. And then you're going to have plus 6kx, but 6kx and minus 6, so we're going to put those two together because they're both coefficients of x. And then finally, we're taking care of this, k squared plus 35, which is our constant term. Because k is a constant in this case, x is the variable. Make sense? Great. Now let's go ahead and clean area. Oops. Uh-oh. All right, great. So that would bother me forever, you know. So now we're going to go ahead and try to make sense of it, right? This is a perfect square. Awesome. This should be a perfect square too, but that's quadratic. That means delta equals 0, or the discriminant, or b squared minus 4ac, whatever you call it, right? So you can go ahead and try that and say, okay, I want the delta on the right-hand side, which is b squared minus 4ac to be 0. Beautiful, right? This is going to bring you a beautiful cubic equation, which you need to solve, and then so on and so forth. But since this is a competition level problem, it probably is a competition problem. And I believe it's from Russia, if I'm not mistaken. And these problems are very common on math competitions, by the way, or math Olympiads. So what happens is we can kind of try to guess the coefficient of x squared, because we want this to be a perfect square. So certain things need to be satisfied. If solutions are rationals or integers, then 2k minus 1 could be an integer perfect square, like 1 or 4 or 9 or 16 or 25 or whatever, right? Can it be 1? First of all, I'm thinking about 1. If 2k minus 11 is equal to 1, by the way, 2k minus 11 is odd if k is an integer and 1 is an odd number. So that's good. Okay, k equals 6 will give me the value. So if k is equal to 6, then I'm going to be getting 36 minus 6, 30x, and here I'm going to get 36. So here's what it looks like. X squared plus 30x plus 36. If k is equal to, wait a minute, did I say 1? Oh no, k is equal to 6. Oh no, okay. If k is equal to 6, that's going to be 36 plus 35. Wait a minute. Did I say k is 1? Okay, start over. K is equal to 6. Okay, I want this whole thing to be 1. So k is equal to 6. All right. So we get x squared. And 6 times 6 is 36 minus 6. Okay, that's a 30x. Good, that works. 6 squared is 36 plus 35 is 71. Uh-oh, that didn't work. Because 71 is not a perfect square. That doesn't work. So you can try this until, well, the next one, I guess, would be 3. In that case, k would be 7. 7 squared is 49. 49 plus 35 is 84. That wouldn't work either. Maybe there's no integer solutions. Who knows? That's why I'm going to leave it alone. Like, just that's for you to finish up, okay? I'm about to talk about the second method because that's the fun part. Okay, the first part is torture, so sorry about that. No pain, no gain. I kind of had to give you some. I hope you enjoyed, because sometimes people say, oh, why you're taking 10 minutes for this problem or 15? This problem is probably going to take more than 10 minutes. And you already did. But anyways, this is why I do it. I kind of share my knowledge with you. I share my passion, energy, and all that stuff. Okay, now, remember, initially we kind of paired these up, right? And that's how we multiplied. So why don't you pair up slightly differently, like these two and these two? And you're like, why? There's a good reason. Look, if you do that, you're going to get something like this. And do you see what I see? Okay, that's beautiful, right? Don't you think? Substitution, yay. So we can go ahead and call this z or t or u, whatever, whichever variable. I don't want to use z because I use it for complex numbers. And I have another channel, did you know that? Called aplusbi that focuses on complex numbers. So go ahead and check it out and let me know what you think. And there are some lecture videos which you can also check out and ask questions. Great. If I call that u, not u, but just the variable u, this is also going to be u. So we're going to get something like this. U times u plus 2 is 35. You see how substitution simplifies your life, but of course you have to manipulate a little bit. Don't manipulate people, but manipulate expressions instead, okay? Now, we're looking at two numbers that are consecutive odd or consecutive even. Their product is 35. Isn't that beautiful? We're still looking at consecutive numbers, but a lot easier. And yes, their product is odd, so they have to be odd. So it's going to be 5 times 7. So u can be 5. But it's like, is that the only solution? No. Because if u is 5, this is going to be 7. So reverse and reverse, or reverse and negate, whatever. Negative 7 is also a solution. Think about why that would be a solution in that sense, because once you know one of the solutions, you can kind of do something, what I did here. Hopefully you can figure that out, okay? If you don't figure it out, just let me know in the comment section and I'm going to try to answer that. But that's a really good technique. So anyways, we got the u values, but u means something else, right? X squared plus 3x. Beautiful. So from here, we can basically set these to the u values, and that's going to give us two equations. Yay! That's why we had originally a quartic, because that gave us two quadratic. You know what that means? It also means that, yay, you could factor this quartic into two quadratics like this and solve like that. But who would know how to factor it? Like, that would be kind of hard. Not too hard given that all the coefficients are integers. But here, if you look at the solutions, it's going to be negative b plus minus the square root of b squared minus 4ac, which is delta. Let's go ahead and evaluate it. B squared plus 20, that's 29, such a nice number. No wonder we couldn't guess it. And then the other two solutions are going to be negative b plus minus the square root of b squared, 9 minus 28. Uh-oh, Houston, we have a complex scenario. That's going to be 19, but with an I, because that's a negative number that you're trying to square root, right? So we have two complex, non-real, and two real solutions. And guess what? This brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out aplusbi, and bye-bye.